Coming up on SpaceTime, Boulders discovered escaping from the asteroid Dimorphos, new features discovered in black holes, and Houston, we have a problem. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered several dozen large boulders swarming around the asteroid moon Dimorphos. Their detection comes in the wake of last year's Double Asteroid Redirection Test, or DART, asteroid impact mission. The mission was designed to see if NASA could nudge a potential Earth-impacting asteroid off course so that it would miss our planet. See, wayward asteroids present a real collision hazard to Earth. Scientists estimate that an asteroid measuring about 10 kilometers across smashed into the Earth 66 million years ago, wiping out 75% of all life on the planet, including all the non-avian dinosaurs. But unlike the dinosaurs, humanity can avoid such a fate if we begin practicing now on how to knock Earth's approaching asteroids off course. Trouble is, this is far trickier than what's been depicted in Hollywood movies. See, planetary scientists first need to know how the asteroid was assembled. Are we talking about flying piles of rubble, in other words, loosely agglomerated rocks? Or are we talking about something more substantial, a single solid boulder, the size of a mountain? This information will help provide strategies on how to successfully deflect a menacing asteroid. Now, as a first step, NASA did an experiment last year, smashing an impactor spacecraft called DART into an asteroid to see what would happen. The half-ton impactor spacecraft smacked into the asteroid Dimorphos on September 26 at approximately 23,000 kilometers per hour. The impact was so severe, it altered Dimorphos' orbit around the larger asteroid Dimorphos by around half an hour. Astronomers using the Hubble Space Telescope have been continuing to follow the evolving aftermath of the collision, and they've now discovered several dozen boulders were lifted off the asteroid following the smash-up. A report in the astrophysical journal Letters claims the Hubble images show boulders looking like a swarm of bees very slowly moving away from the asteroid. This might mean that smacking an Earth-approaching asteroid itself could result in a cluster of threatening boulders heading in our direction. In other words, instead of one single big asteroid, you could have a whole bunch of little ones. Now, based on Hubble photometry, the 37 free-flung boulders range in size from around 1 to something like 8 meters across. And although they're traveling with the asteroid, they're also slowly drifting away from it at a little more than 1 kilometer per hour. The total mass of these detected boulders is thought to be about 1% of the mass of Dimorphos itself. The study's lead author, David Jewett from the University of California, Los Angeles, says it's a spectacular observation, showing a cloud of boulders carrying mass and energy away from the impact target. And the numbers, sizes and shapes of the boulders are all consistent with them having been knocked off the surface of Dimorphos by the impact. Now, this tells scientists for the first time what happens when you hit an asteroid and see material coming off it. Jewett says it opens up a new dimension for studying the aftermath of the DART experiment using the European Space Agency's upcoming Hera spacecraft, which will arrive at the binary asteroid system in 2026. Hera will perform a detailed post-impact survey of the target asteroid, and the boulder cloud will still be in the process of dispersing when Hera arrives. Jewett says it's like a very slowly expanding swarm of bees that eventually will spread along the binary pair's orbit around the Sun. He says the boulders are most likely not shattered pieces of the asteroid caused by the impact, but rather they were boulders already scattered on the asteroid's surface, the type seen during the last close-up images taken by the DART spacecraft just 2 seconds before the collision when it was about 10 kilometers above the surface. Jewett estimates that the impact shook about 2% of the boulders off the asteroid's surface. He says the boulder observations by Hubble also give an estimate for the size of the DART impact crater. He says the boulders could have been excavated from a circle about 50 meters across on the surface of Dimorphos. Hera will eventually determine the actual size of the crater. Long ago, Dimorphos may have been formed from material shed into space by the larger asteroid Dimorphos. The parent body may have spun up too quickly, or it could have lost material through a glancing collision with another object. The ejected material then formed a ring that gravitationally coalesced over time to form Dimorphos. and this would make Dimorphos a flying rubble pile of rocky debris loosely held together by the relatively weak pull of gravity. Therefore, Duet says the interior is probably not solid, but is a structure more like a bunch of grapes. It's not clear how the boulders were lifted off the asteroid's surface. They could have been part of an ejector plume that was photographed by Hubble and other observatories during the DART impact. Or a seismic wave from the impact could have rattled through the asteroid, sort of like hitting a bell with a hammer, shaking loose the surface rubble. Duet says that monitoring the boulders' future movements may provide enough data to pin down their precise trajectories, and that will allow scientists to determine in which directions they were launched from the surface. This is SpaceTime. Still to come, astronomers have identified a new feature of black holes that sounds like it may have come straight out of a science fiction novel. And Houston, we have a problem. The blackout that affected the Johnson Space Center. All that and more still to come on SpaceTime. Astronomers have identified a new feature of black holes that sounds like it may have come straight out of a science fiction novel. They've detected a quasi-periodic oscillation signal embedded deep in a microquasar beaming out of a distant black hole. Black holes are immense gravitational wells created by the death of massive stars in core collapse supernova explosions. The gravitational force of these objects is so strong that the escape velocity from a black hole would exceed the speed of light. And since nothing can travel faster than light, nothing, not even light, can escape a black hole, hence the name. Once beyond the black hole's event horizon, a sort of point of no return, matter and energy will fall forever towards the black hole's singularity. However, outside this event horizon, material can still escape. When material comes into contact with the area around a black hole, it's scooped up into an accretion disk where immense gravitational forces crush and rip it apart, releasing vast amounts of energy and material. These are guided by powerful magnetic forces into beams travelling perpendicular to the accretion disk, often at superluminal speeds. The most powerful of these beams, which emerge from supermassive black holes, millions to billions of times the size of their stellar counterparts, and found at the centres of most galaxies, form quasars bright enough to be seen across the other side of the universe. But a subset of accreting stellar mass black holes can also launch jets of highly magnetized plasma referred to as microquasars. Now, a report in the journal Nature studying a galactic microquasar, catalogued as GRS 1915+105, has discovered features in the quasar that have never been detected before. Using the 500-metre aperture spherical radio telescope in China, astronomers have for the first time detected a quasi-periodic oscillation signal in the radio band of the quasar. Quasi-periodic oscillation signals are a phenomenon that astronomers use to understand how stellar systems like black holes function. And while they've been observed in X-rays from microquasars, their discovery in radio emissions in the quasar is unique. The study's lead author, Wei Wang from Wuhan University, says the quasi-periodic oscillation signal had a rough period of about 0.2 seconds. That's a frequency of about 5 Hz. Now, such a signal doesn't always exist and only shows up under special physical conditions. The authors were lucky enough to catch the signal twice, once in January 2021 and again in June 2022. This unique feature may provide the first evidence of activity from a jet launched by a stellar mass black hole. Now, under the right conditions, some black holes in binary systems will launch a jet, a mixture of parallel beams of charged matter and magnetic material that's moving at close to the speed of light. The detailed mechanism to induce this temporal modulation in a relativistic jet hasn't been identified. However, one plausible mechanism would involve the jet's direction regularly changing and then returning to the original direction once every 0.2 seconds. A misalignment between the spin axis of the black hole and its accretion disk could cause this effect, which would be a natural consequence of the dragging of space-time near a rapidly spinning black hole. What astronomers and physicists refer to as frame dragging. It's a fascinating prospect. This is SpaceTime. Still to come, Houston, we have a problem. A blackout hits the Johnson Space Center in Houston, Texas. And we look at the giant star Antares, the second nearest star system to the Sun, Barnard Star, and the annual Perseids meteor shower. All that and more coming up on August Skywatch. Well, it was very much a case of Houston, we have a problem when a power outage disrupted communications between Mission Control and the crew aboard the International Space Station. The sudden blackout during work to upgrade other equipment at the Johnson Space Center prevented mission managers from sending commands to the space station or talking with the orbiting crew. While the crew were in no danger during the outage, it still took 90 minutes for backup power to come online. The on-station crew were told of the problem by Russian mission managers at their control center in Moscow about 20 minutes into the failure. It's the first time NASA's had to fire up the backup systems to take control, something which should take place instantaneously when power is accidentally lost. NASA also maintains a backup control center on the outskirts of Houston in the event of a hurricane or other disaster requiring evacuations from the Johnson Space Center. But mission managers didn't need to move this time as the lights and air conditioning kept working because they were on a different circuit. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for August on Skywatch. August is the 8th month of the year in the Julian and Gregorian calendars. It was originally named Sextilis in Latin because it was the 6th month of the original 10-month Roman calendar under Romulus in 753 BCE when the year started in March. It only became the 8th month when January and February were added to the start of the year. In the year 8 BCE, it was renamed in honour of the Roman statesman and military leader Augustus, who had achieved several military victories, including the conquest of Egypt during the month. Okay, turning to the heavens, and the constellation Scorpius the Scorpion is high overhead this time of year, covering almost a third of the August night skies. At the heart of Scorpius, located some 470 light-years away, is the red supergiant Antares. A light-year is a distance of about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Red supergiants have the largest diameters of any known star. They evolve out of main sequence stars with more than 8 times the mass of the Sun. A main sequence star is a star fusing hydrogen into helium in its core. When stars stop fusing hydrogen into helium in their core, the balancing act between gravity pushing a star's mass down towards the centre and energy from nuclear fusion in the core pushing outwards ceases, and gravity wins, causing the star to begin to collapse inwards, crushing the stellar core until the increase in pressures and temperatures trigger helium fusion. At the same time, a shell of hydrogen around the core begins to fuse, causing the star's outer gaseous envelope to expand out into a bloated giant. And now, being further away from the core, the stellar surface starts to cool down, becoming redder in colour. While Sun-like stars will become red giants, those that are far bigger, 8 times or more the mass of the Sun, become red supergiants. Supergiants will fuse all their core helium into carbon and oxygen within just a few million years. They'll then begin fusing this core carbon and oxygen into progressively heavier and heavier elements until they eventually begin to produce iron in their core. Now, no star, no matter how massive it is big enough to fuse iron into heavier elements. And so then the star will collapse catastrophically in what's known as a core collapse supernova, an explosion bright enough to outshine an entire galaxy. The end result of this core collapse supernova will be the creation of either a neutron star or a black hole, depending on the progenitor star's mass. The name Antares means rival of Mars, and indeed when they're close together in the sky, they do look very similar. Antares, or Alpha Scorpii as it's sometimes called, has some 12.4 times the mass and an incredible 450 times the diameter of our Sun, and is one of the largest known stars in the universe. Antares is so big that were it placed where the Sun is at the centre of our solar system, it would engulf all the inner planets, Mercury, Venus, Earth and Mars. Its outer surface would reach almost as far as the orbit of Jupiter. Antares is a binary system. There's a companion star orbiting with it called Antares B, a massive spectral type B blue-white star, at least 7.2 times the mass and 5.2 times the radius of the Sun. It's located about 224 astronomical units beyond the primary star. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres or 8.3 light minutes. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're closely followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Now, each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now, put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located near Antares is the spectacular globular cluster Messier 4, or M4 for short. Named after the 18th century French astronomer and comet hunter Charles Messier, it's one of a catalogue of 103 fuzzy objects which weren't comets, and so were of no interest to Messier, and so he made a list of them, so he didn't waste his time looking at them. Other astronomers have since added further celestial objects to the catalogue, bringing the total to around 110. Located some 7,000 light-years away, Messier 4 can be seen through a pair of binoculars, making it one of the closest globular clusters to Earth. Globular clusters are densely packed spheres containing thousands to millions of gravitationally bound stars, which it's thought were either originally all born at the same time in the same stellar nursery, or are the surviving cores of galaxies that have been cannibalized by larger galaxies. They're almost always found orbiting the halo of galaxies. The Milky Way has about 150 of them, and they're all usually very ancient, some dating back to around 12 billion years. Located just below the sting of Scorpius are two open star clusters, M6 and M7. M7's the nearer of the two, located about 800 light-years away, while M6 is a more distant 2,000 light-years. Open clusters are less densely packed than their globular cluster counterparts, with the stars inside them less gravitationally bound and more prone to drifting away over time. Another open star cluster in Scorpius is NGC 6231, located about 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 is a bright open star cluster containing around 120 stars, including a significant population of highly luminous supergiants, numerous white-yellow stars, and at least 2 Wolf-Rayet stars. Wolf-Rayets are extremely luminous evolved stars reaching the ends of their lives. Having run out of hydrogen for core fusion, they're no longer on the main sequence and are instead fusing progressively heavier and heavier elements in their cores. This causes them to have surface temperatures of up to 200,000 degrees Celsius, and such extreme temperatures generate powerful stellar winds. Just behind Scorpius is the constellation Sagittarius, the half-man, half-horse of Greek mythology. And as we mentioned in last month's Skywatch, the centre of the Milky Way galaxy is found in Sagittarius, roughly 27,000 light-years away. The name Sagittarius can be traced back beyond the Greeks to the ancient Mesopotamian archer god Nergal. Sagittarius is known for its many nebulae and clusters, more than any other constellation. One of the largest and brightest is the globular cluster M22, big enough to be visible to the unaided eye. Located about 10,600 light-years away near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, the plane in the sky upon which all the planets orbit the Sun, and it contains over 70,000 stars, covering an area of around 100 light-years. It also contains at least 2 black holes, and is one of only a handful of globular clusters known to contain planetary nebulae, the puffed-off outer gaseous envelopes of dead Sun-like stars. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation Ophiuchus, the healer or serpent bearer, often portrayed as a snake coiled around a man. In Greek mythology, Ophiuchus raises Orion from the dead after he was bitten by Scorpius. Ophiuchus contains several star clusters and other interesting features, including Barnard's star. Barnard's star is the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located some 5.9 light-years away, Barnard's star is a spectral type M red dwarf, about 0.144 times the mass of the Sun. Our Sun is around 4.6 billion years old. At between 7 and 12 billion years of age, Barnard's star is considerably older than the Sun and may be among the oldest stars in the Milky Way galaxy. It's lost a great deal of rotational energy, and its periodic slight changes in brightness indicate that it's rotating about once every 130 days. By comparison, our Sun rotates roughly once every 29 days. Given its age, Barnard's star was long assumed to be quiescent in terms of stellar activity. But in 1998, astronomers observed an intense stellar flare, indicating that Barnard's star is indeed a flare star. Flare stars are variable stars that can undergo unpredictable dramatic increases in brightness lasting a few minutes. It's believed that the flares of flare stars are analogous to solar flares in the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. Lying just to the west of the Scorpion is the constellation Libra, the Scales. In Greek mythology, Libra represents the claws of Scorpius the Scorpion. However, the Romans considered Libra a distinct separate constellation from Scorpius and thought them to be the scales symbolizing the equinoxes, the times of the year in March and September when the Earth gets equal lengths of day and night. That's because 2,000 years ago, when all this was made up, the Sun moved into Libra at the time of the September equinox. But due to precession, as the Earth's spin axis wobbles in direction, this point in time has now moved into the adjoining constellation of Virgo. If you look to the south in the Southern Cross, that's the constellation Centaurus, another half-man, half-horse mythical beast. Centaurus was the teacher of many of the Greek gods and heroes. He was placed among the stars in the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star nearest the Southern Cross, Beta Centauri, lies NGC 5139, Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the ancient Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. It has a diameter of more than 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another very ancient globular cluster, around 12 billion years old, and it contains many so-called population 2 stars. These are the second generation of stars to have formed, and were created directly out of the remains of the very first stars in the universe. Stars in the core of Omega Centauri are so crowded, they're estimated to average only 0.1 light-years away from each other. And that compares to the nearest star to our Sun, Proxima Centauri, which is some 4.2 light-years distant. Located close to Omega Centauri in the sky is the giant lenticular galaxy NGC 5128 Centaurus A, which we see looking like it's split in half by a thick band of dust. The galaxy was discovered in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a time long before the bright lights of a modern city would make such a discovery impossible. Located some 13 million light-years away, Centaurus A is one of the strongest radio sources in the sky and is thought to be the result of a merger between an elliptical and a spiral galaxy. It can be easily seen using a pair of binoculars, but you'll need a telescope to make out its spectacular dust lanes. August is also the time of the peak of the annual Perseids meteor shower. The meteors are the debris trail ejected by the comet Swift-Tuttle as it travels along its 133-year orbit through the solar system. As its name suggests, the Perseids radiant, that is the point in the sky from which the meteors appear to originate, lies in the constellation of Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of its activity going back almost 2,000 years. They're active between July the 17th and August the 24th, with a peak on August 12th with around 60 meteors an hour being visible. The Perseids are very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're best seen between midnight and just before dawn, producing long, bright trails and some fireballs. Most Perseids burn up in the atmosphere at altitudes of over 80 kilometres. They're best seen from the northern hemisphere, so for southern hemisphere skywatchers, look to the north with the radiant below the northern horizon. There are 2 full moons in August. The first occurred on August the 1st. It was a perigee full moon or supermoon because it was a bit closer to the Earth than average and consequently appeared slightly larger, although you wouldn't have noticed it in real life. By the way, this was the 4th supermoon in a row and the biggest and brightest supermoon of the year. Now, the Farmer's Almanac also listed this full moon as a sturgeon moon, named after North America's biggest fish because large numbers of sturgeons are found in the Great Lakes this time of year. In other parts of the world, it's often referred to as a grain moon, a corn moon, a lynx moon, and even a lightning moon. So you've got plenty of names to choose from. The second full moon of the month will be on August the 30th, and that will make it a blue moon according to some definitions. However, NASA says the traditional definition of a blue moon refers not to the second full moon of the month, but the third full moon in a season that has 4 full moons. Turning to the planets now, and Venus and Jupiter have both dropped into the solar glare, ending their lengthy reigns as evening stars. Mercury remains above the horizon in the western evening twilight at magnitude 0, with Mars 6 times fainter than Mercury hovering just above it. On August the 9th, the Moon will form a pre-dawn conjunction with Jupiter. And on August 20th, Venus will rise before dawn, becoming the morning star for coming months. On August the 27th, Saturn will arrive at opposition, its brightest of the year. This means it'll be directly opposite in the sky from the Sun, making a spectacular nighttime observational target. Saturn now rises at sunset and remains out all night. And on August the 30th, Saturn will hover just above the full moon after nightfall, and as Saturn is at its best right now, it'll be easy to identify by using the full moon as a guide. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.